The z-score when you're given an area or percent. I call these backwards ones because you have to look inside the normal distribution chart and go back out to the edges to get the z. So on these, that's why I call them backwards ones. And you're kind of back solving once you do it in an equation also. So what we're going to be given here is something inside of here. We're going to be given a number inside of either here or inside of here. We're going to find that corresponding area and then go back out to find the z. So your answers are going to be actual z-scores here or here because I'm going to be giving you one of these areas inside or percent inside. So that's why I call these kind of backwards ones. So let's start. All right, so example 1, we're going to find the z that corresponds to the top 10% of a normal curve. When doing these problems, we want to find the top 10%. So we're just going to kind of estimate and say where we think the top 10% would be. So I'm thinking like maybe the top 10% is around here. That's good enough. You're just doing this as a visual. Okay, so I'm telling you that I want to find this z that cuts off this area that's a top 10%. This would be, I want to find the cutoff score for the top 10% of SATs. I want to find the cutoff score for the top 10% of a placement test, like MCAT or something like that. So this is going to give us a top 10%. Now, if you look at it, when you find the top 10, you're also finding the 90th percentile. Can you see that? The z of a top 10 is the same as a z of a 90th percentile. The z is like slicing the curve into pieces. So a 90th percentile means you did better than 90% of the population. Okay, so we need to find this z. Obviously, we're on the positive side, right? So obviously, we're on the positive side. So when we go over here to look up the z, to get the z, we are given this area right here. So we are given this area of 10%. Well, that's not what the curve represents. The curve represents, and this is the z we're trying to find. The curve represents this shaded right here. So these shadings just are so your eyes don't go crazy. They don't really mean anything. It's so that every 5 rows they change a color, so it helps your eyes to see. Anyway, so going back to this, this is 10. So if this is 10%, this is 90%. So what we're going to look up is this shaded area down here, because that's what this corresponds to. So I'm going to turn this into 4 decimal places because the area is 4 decimal places. So I'm going to make that 9,000. And remember, this goes from 5,000, a half of the curve, all the way to the whole curve. This shaded area would increase this way. So if I go, I'm going to look up the closest thing to 9,000. So here's an 8,900, 9,049, 8,997 right here, and 9,015 here. So you go with what's closer. This is 8,997, that's 3 away, and this is 15 away from 9,000. So we're going to go with this one because this is the closest. So we're going to say the z is go out and over, and my z is 1.28. And we're on the positive side because this area is over 50% here. So go back, and our z is just positive 1.28. All right, let's try another one. Next one, we want to find the z that corresponds to the bottom 30%. Remember, this is our 50% line. So the bottom 30% would be approximately here. Maybe even a little more. Let's make it a little more. We're just estimating. So this is 30. This is the bottom 30%. If you want to think about it as a line drawn, this is your z. This would be 30, and this would be 70. So we go back to the normal distribution. We're on the negative side because we're less than 50%. Go back to the negative side. We were given this bottom 30, so we're given 30. I'm going to make it into 3 decimal places. I don't have to change anything because this is the area that I was given, and this is the area I'm trying to look up. So I'm going to look up the closest thing to 3,000. I'm gonna have to slide this down a little. If you go into the 3000s or down here, and you're going to get something like 3000. There's a 15, a 281. So let's see what's closer. This is 15 away from 3000. And this is 19 away from 3000. So we're going to go with this one, negative 0.52. Negative 0.52. So that Z is negative 0.52. How did I get that? I was asked the bottom 30%. I went to the bottom 30%. That would be this area here. That's 30. I made it into 3000 because all of my areas and percentages go to 4 decimal places. So I just want to make it look like this. So I just add some zeros at the end. And then I go and I look for the closest thing to match 3000. I got 3015 and 2918. This is 19 away, 15 away. So we went with that. Went back out to negative 0.5 and then up to 2 when you go up at the top. Now, let's talk about the top 30%. So if I asked you to find the top 30%, watch what happens. So these are the people that are in the bottom 30% of times or scores. These people would be in the top 30%. Okay, so that's 30. Draw a Z in the line in the sand. That's what we're trying to find. That's 30, right? Let's go over here. Now we're on the top 30, so we're on the positive side. And let me clean this up. Okay, so this was 0.30. I don't want that. I don't want to look up that. I can't look up 30. I got to look up this area. That's 30. That is 70. So I'm going to be looking up the shaded area all the time. You've got to find, when doing this, the area that's shaded to look this up, because that's the area it corresponds to. So I'm going to look up 70, add my 2 zeros, and I look up 70,000. The closest thing to 70,000 is this right here, which is 15 away, 6,985, and this, which is 19 away. Doesn't that sound the same thing? Wasn't it 15 away and 19 away over here? And look at your answer. The answer is positive 0.52. We're going to go with the one that's 15 away, not 19 away. It's positive 0.52. So they're symmetrical. They're mirror images of each other. So that means this Z is positive 0.52. So a Z that corresponds to a top 30 and a bottom 30 are exactly the same distance from the mean. They're the same distance from the mean. The only difference is this tells me I'm on the positive side and the top 30. This tells me I'm on the negative tail and the bottom 30. Okay, remember, just as a reminder, we never subtract z-scores. We only subtract areas. The z's are places, or place values on this normal curve. Alrighty, so now let's look at a z that corresponds to the middle 50%. All right, so here's the z here. And we're going to go about middle 50% is a little less than that 68. Remember, this is 68 from our previous lesson. So we're going to say that this is 50%, 0.5. We're going to come up with 2 z's now. One of them is going to be a positive, and one of them is going to be a negative. We will use this in application problems when I asked you, what's the middle 50% of weights in the nation? What's the middle 50% of heights? What's the middle 50% for blood pressure? So those are the questions that I'm going to ask you between these two. All right, so you're going to end up getting 2 different answers, one above the mean and one below the mean. All right, so let's look at our numbers here. This is 50. That means the rest of the curve is also 50. We're going to have 25 here, and we're going to have 25 here. So we have a tail of 25 and another tail of 25. So let's go to our normal distribution chart. Let me clear it up again. Okay, and now let's talk about what we have. We have a 50. We have a 50 right here, 0.5 in between those two. And then we said this was 0.25 and this was 0.25. So over here, we had that middle 50 is this area. And we have this is 0.25 and this is 0.25. All right, so it's the same thing on this graph. So it doesn't matter. We're going to look up, let's look up the negative side first because that's the easier side to look up. So we're going to look up this corresponding area of 25%. Add 2 zeros, and we go to the closest thing that is 25%. So the closest thing that is 2,500. Down here, where are we? We're somewhere around here, 2,500. There's 2514, which is 14 away, and 2483, which is 17 away. So we're going to go with this one right here. So the answer to that one on the negative side is negative 0.67. Okay, so right there, and we'll transfer that back in a minute, negative 0.67. Now let's do it on this side. So they had the middle 50%. And then this was 25 and this was 25. So we want this total area to look up this. So this total area is 7,500. 75 and add 2 zeros. So that's the area I'm going to look down here. So 7,500, closest thing to 7,500. You should figure this out. Do you hear my dog snoring? This is 14 away and this is 17 away. Same thing I said over here. So we're going to go with the one that's 14 away, and you get, look at that, 0.67. So that's a positive 0.67. They're symmetrical curves. They're the same distance from the mean. So either way you want to do it, you're going to get a positive 0.67 here, and you'll get a negative 0.67 here. Why are they the same number? This is 0. This is the distance from 0. How many standard deviations you're adding from 0? This went up 0.67. This went down 0.67. Right, so that's why we get the middle 50%. All right, example 4. Let's do another one. You try this one and then pause it and see if you can get the answer. So a z that corresponds to the middle 60% of the normal curve. So let's pause it and you try it and then go back. So I'm going to go through and I'm going to do it. So that's 60. That means this is 40. And I have a 20 here and a 20 here. Go over to my distribution charts, clear everything out. So this was a 60. And that's a 20 then, and a 20. That's a 60. So this is a 20 and a 20. So over here, I'm looking up 2,000. And then the closest thing to 2,000 I will look up. The closest thing to 2,000 is right here, 2005. So my z is negative 0.84. So that's the negative side. And over here, if I'm going to use this side, I have to find this total area. That would be 0.8 added together. That's the area I would have to look up over here. And if I look up 8,000, I'm going to get this right here, which is 5 away, just like the other one, it's symmetrical, and I will get positive 0.84. Okay, so on this one, I'm going to get positive 0.84 and negative 0.84. Hope you did that one right. Okay, last couple, we're almost done here. Says find the z-score so that 75% of the area is to the right of the z. Okay, so we want a z-score. So let me say if I put a z-score here, I want a z-score somewhere so that 75% of it is to the right of it. Okay, is that possible? Is that right? Is that correct? Yes. Let's say I put it over here. If I put it on the positive side. If I put a z on the positive side, there's no way to get 75% to the right of it. This whole half of the graph, is 50%. So if I want a z-score so that 75% is to the right of it, I'm going to have to go into the negative. All right, so let me say that again. Let me clear that out and say that again. Okay, so let's say I want a z that 75% is to the right of it. This is 50, that's 50% of your graph. So if I put a z here, there is no way to get 75%. The biggest amount I can get, if my z is on this side, or if it's even at the mean, to get to the right of it is 50%. So the z has to be down here, so I can get the 50 plus another piece. So we're going to be looking at a negative z. Okay, so we're going to be looking at the negative side. All right, so here we go. I want a z so that, here's my 0, so that 75% is to the right. So this is my 50, right? That's 50 plus another 25 here. So if this is 50 and that's 25, then this has to be 25. So I'm looking for a z that has 75%, 50, which is half, plus another 25% to the right of it. So that means this is 75, this has to be 25. So I'm on the negative side. So I'm going to look up the z that has the closest thing to a negative 2500. And we did that one before. So a negative 2500 is going to be, negative 2500 is negative 0.67. And just follow along. It starts at 0 and goes to 50, like 50% if you keep going, okay? Here's 50, it goes from 0 to 50 as you go along. So here's 2500 approximately. And we did this one before, negative 0.67. So the answer to that is negative 0.67. That's your z that corresponds to 75% to the right, 25% to the left. We got this answer before when we just did this because we did the middle 50. Okay, so the middle 50 and the bottom 25% is pretty much the same thing. So look, see how this z here? This z divides it into a bottom 25 and a top 75. That's why it's the same z-score. A z-score is just a place on the graph that divides areas. All right, so this should be our last one for the day. Oh, no, 2 more. All right, here we go. Find the z-score so that 42% of the area is to the left of the z. All right, so if we want it to the left of the z and we want 42%, we've got to be on this side because this is 42% to the left of it. We can't be on this side because if we have a z on the right-hand side, any z over here has 50 plus to the left of it. Any z on the positive side has 50 plus some more to it. So we have to be on this negative side. Okay, so we're going to look up the closest thing then to 4200 on the negative side. So 4200. 4207 looks pretty good. So 4207. So negative 2 negative 0.2. That's it, negative 0.2. So the z is negative 0.20. It's just negative 0.2. And that is your z-score for 4,200 to the left. And then now we're done. And I see a typo. So find the z-score so that 48% of the area, I should say area, is to the right of the z. All right, so we want 48% of the area to the right. Well, we can't be over here because if it has to be, the area has to be right up at this is 50 plus. So we have to be on this side so that if it's less than 50%. Just sketch the graph and you can figure it out. Okay, so 48%, well, it should actually be even more than that. It should be closer into 50, right? So 48% is to the right of the z. So our z is going to be here, and 48% is to the right. All right, add our two zeros. And we're going to go to 48% is, we're on the positive side, but look what happens. This is messy. Let me clean all this up. Okay, so this area right here, where the z is 48%. We can't look that up. Remember, we talked about that, right? So we can't look up 48. So what do we have to look up? Well, we have to look up this area. So we have to look up 5,200. If we're looking up this side, we can't look up these areas to the right. That's white. Areas to the left are the ones that you're always trying to look up. So 5,200. So I'm going to look up the closest thing. Starts at 5,000. 5,199. Looks like that's it, right? So it's almost right on the mean. So this is really, really close to the mean. Look at that, 0.05. So this is really, 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 really close to the mean. So we have to move this even in closer. It's almost there. It's a half. Whoop. Is it 0.05? Yeah. So 0.05. So let me just 0.05. Almost right at the mean. Okay. So that's going backwards. So now you know how to be given a z and find it, and now you know how to be given an area and find that one.